I'm going to discuss a topic about determinate plane frames. When you say determinate, it means that it can be solved using the three conditions of equilibrium: summation of force along x or horizontal equal to 0, summation of force along the vertical equal to 0, and summation of moment about any point equal to 0. Okay. Um, Recall that a frame is composed of several connected members that are either fixed or pin connected at their ends. So, kung fixed, it can resist movement. Pag pin, it cannot resist movement. Now, the design of these structures often requires drawing the shear and moment diagrams for each of the members. So, to analyze any problem, we can use the procedure for analysis outlined in beam. So, as if that you are analyzing a beam. So, this requires first determining the reactions at the frame supports, and then using the method of sections, we find the axial force, the shear force, and the moment acting at the ends of each member. And then last, provided that all loadings are resolved into components, ang ginamit yung components along the member, along the axis, and perpendicular to the axis of the member, kana component, because they are inclined members. So you have to reorient your axis. So provided all loadings are resolved into components acting parallel or perpendicular to the member's axis, the shear and moment diagrams for each member can then be drawn as described previously. So, given a particular frame, ikatra nimo sa junction, member gan ba? At the ends of each member, ikat nimo and consider it as a beam with three unknown forces: axial force, shear, and moment. And then after that, pag ma-prove na nimo na in equilibrium siya, na-check na nimo tanan, and then you can start drawing the shear and moment diagrams. Okay, so let us solve four problems here. The first one is this. Draw the shear and moment diagrams for each member of the frame. Assume the support at A is a pin and D is a roller. So, pag pin, there are two reaction components. One, along the member and perpendicular to the member. Ano? And since the member is vertical, then ang components sa reaction, horizontal and vertical. And then for this, since this is assumed to be a roller, you only have one reaction component, vertical. So we have three unknowns, we have three conditions of equilibrium, then we can solve for these reactions. So first, sum up summation of force along x equal to 0. So for this uniform load, we have to convert this one to a resultant force. We have this, no? 0.6 times length niya 16, you have 9.6 skips. So, summation of force, we only have two horizontal forces. This one, no? RAX. Now, remember, you can predict already that RAX is directed to the left, considering that this load is directed to the right. Pero, for purpose of demonstration, let's assume na ang horizontal directed to the right, ang vertical directed upward. Assumption lang man. So after solving, and negatives therefore, wrong na yung assumption. Kaya nag-negative man ta. Therefore, dili siya right, left. The horizontal component of RA is directed to the left. 9.6. And then, summation of moments sa A, because we cannot use summation of force sa Y since we still have two unknown forces. So, we will sum up moment at A or D. And before tayo mag-start, asa taning kuhaan o resultant. 0.8 times 20, you have 16. So, mo na equation moment. RD times 20 minus 16 times 10, 1 half of 20, minus 9.6 times 8, 1 half of 16. And RD is positive, meaning our assumption is correct and it is directed upward. And then last, summation of force sa Y, we can solve for RAY. And positive siya, it means na ang assumed direction is correct. So, these are our reactions. So, after this, base procedure, after this, i-cut na to at the junction at B and then at C. Okay? And then consider each member as a beam. So, we have this reactions, cut na diya, and then cut it to the C. And then, let's analyze per member. No? So, we'll start with EB and BC and then last is CD. Checking na to ang last member. So, for EB, we have this. Okay? 9.6, 4.16, 0.6, 16 feet. So, nagkata sa B. And, let's check, no? Bali, kini sa internal forces, the rebalancing ni siya. Yang i-balance ang applied forces or load. So, resultant, 0.6 times 69.6. You'll notice na the two horizontal forces, magda-balance lang, 9.6 to the left, 9.6 to the right. Therefore, wala na kay shear dire. Zero na yung shear. Sa vertical, you only have one force, 4.16. Therefore, i-balance siya og downward. 4.16. And then, moment. So, get the moment of this, 9.6 times 16 against 9.6 times 8. You will notice that the moment of this force is smaller compared to the moment of the reaction. So, ang net force, ang net moment ilang duha is clockwise. Therefore, i-balance na to o counterclockwise. Kaya gamay man eh. Okay. And, sorry, 0 and 76.8. Oh, 9.6 times 16 minus 9.6 times 8. The result is 76.8. Clockwise, because this one is bigger, has a bigger moment as compared to this. So, i-balance na to o counterclockwise na 76.8. Next is BC. Cut ka sa B, cut ka sa C. So, since internal ni, pag transfer to sa B, opposite na. Like, kini zero naman eh. We no longer have a horizontal internal force. Vertical, downward man eh, upward eh. And then, counterclockwise ni, clockwise siya dire. So, downward, upward, counterclockwise, clockwise. And then, C is balancing ko dyan. So, 0.8 times 20. Remember, okay. Vertical, 16 downward, we have 4.16 upward. So, kulang ang upward, no? The value is the difference of 16 and 4.16. So, that's 11.84. So, balance na ang vertical. Moment na lang. You get the moment. 16 times 10. That's counterclockwise against 4.16 times 20 plus 76.8. Ma-add ang duha ka moment. I-check ni mo and 0 siya. Okay. butangan lang nato pero zero sa pwede ra pud wala. Okay. And then after this member CD then. Okay, so this member CD, the reaction is 11.84 and 16 feet. Zero naman eh, you only have this one. So upward na eh, vertical, downward ka lang. And to check, balance oh. Therefore, our analysis is correct. And so we are now ready to draw the shear and moment diagrams for each member. So for member AB, we have this okay, and 16 kina, no? And then BC lang, and then CD. So let's start with AB. So draw the lines and then shear. So upward, no, to the left is 9.6, and then uniform load ni straight line, di ba? The resultant is 9.6 also. So 9.6 minus 9.6 mag 0 lang na dyan. Ano? Wala po kayo force din. And then moment. So sa moment, of course, 0 plus area. Area of this diagram. This 1/2 of 16 times 9.8. And the answer is 76.8. No? So ang curvature is supposed to be okay, going this way. Pero positive man, mag-mirror ka, and mo na yung diagram. Okay? So, mirror, mo na yung form. 76.8. And then to be balanced by this is positive man. Diba? In moment, the beam smiles. Sa beam analysis, if the beam smiles, positive na siya moment. So, and then for axial, compression is 4.6 compression also. Negative. Para dili ka ma-confuse, kung ato na tungod ang label, mo tong 0, and then going this way, positive, going that way, going to the right, negative siya. Kaya naman diri itong member. Okay. So for BC, okay, shear diagram, natay upward, 4.16, and then straight line, no? 16 sad, 0.8 times 2016, so 4.16 minus 16, I have negative 11.84, and then we have this reaction, zero. And then we solve for x, bali the point of zero shear, because this is the point where moment is maximum. So to solve for x, you can use my technique, nearest technique, 4.16 shear divided by uniform load, 4.16 divided by 0.8, that's 5.2. And then you cannot draw the moment diagram. So at B, naana kay 76.8, ana, 76.8, plus the area of this, 1/2 of 5.2 times 4.16, the value is added to 76.8. Ang curvature is downward, supposed to be concave upward, pero going down, pero positive man, mirror man yung curvature. So area of this plus 76.8 is equal to 87.616. And then area, One half of how much is this? 14.8 times 11.84. The area is equal to this. So minus money, ang curvature niya is concave downward. So as is lang na siya. No? And then we don't have any axial forces. So as is lang na itong axial diagram. And then for member CD, we don't have shear forces. So kung wala tayong shear diagram, wala siya tayong moment diagram. We only have axial force diagram. Compression eh. So compression minus ano. Now, okay. Normally, sa problem sa determinate frames, you are required to show the combined moment diagram. Pwede sa combined shear diagram, pero usually lagi na require combined moment diagram. So, ipang superimpose natin moment diagram of AB, BC, and CD, and we have this. Okay? This is the combined moment diagram. Okay. So, yun na lang mag-analyze o determinate plane frame. So, the problem is very basic. Okay? Very basic. Now, situational ta. Okay? So, the next problem is similar to the previous one, but there is a load at the joint. So, what are you going to do if there is a load acting at the joint? Okay. So, sige. Again, we'll start with reactions. RAX, RAY, and RC. You know, since the assumption is pin connected at A and C is a roller. So, solution, sa upward force along the horizontal or X, you have 3. Negative 25, therefore RAX is directed to the left. And then summation of moment, we need to resolve this one or get the resultant of this. So 4 times 10, di ba? Acting at the centroid, 40. So let's sum up moment at A. Have RC times 10, 40 times 5, 10 times 4, 15 times 8. And then you solve for RC. It's equal to 36 keeps upward. Okay. And then summation of force sa Y, masolve ni mo ang RAY, it's equal to 4 keeps upward. And mo niyang reactions. So after this, okay, magkat kag section, no? Using this result, the frame is then sectioned into two members, AB and BC, and the internal reaction at the joint ends of the members are determined. Okay. Now, this is not a normal case sa frame na mukat ka diretso sa B. Pag nagani load sa B, what you will do is, for member AB, magkat ka before sa load, before pa ang 15, no? Just to the, kung consider kay AB, local axis ni mo, X, just to the left of 15. Bali, di na maapil ang 15, ha? But still, the length of AB is 8 gihapon. Pero di lang natin consider ang 15. Similarly, for BC, mag-cut ka before sa load, diri ka mag-cut, 10 gihapon pero wala load appeal. And you'll have to analyze joint B separately. So, mo ni ang buhaton nimo. For member EB, wala ni 15, you only have this one. 4 reactions, 4 and 25, 10, sa diha ka nag-cut sa B. Wala 15 na. Balance, alang tayo, no? Nakay 25, nakay 10, so kulang ka o 15 to the right. Ana sa, di ba? And then upward 4, naka downward 4. And then moment na yun. So pag moment sa B, we only have two forces that can produce moment, 25 and 110. No? 25 times 8, that's 200. Tama ba? 25 times, oh. And then 10 times 4 is 40. So there's a difference of 160. So, and the bigger moment is clockwise. Therefore, ang resisting na to, it should be counterclockwise, 160. Okay. Now, before nimo ni transfer sa B, mag-analyze sa kadaan sa joint B. This is joint B. Oh. Naa diyan 15. Eh? And then i-transfer na nimo ni. Opposite yung direction sa like ang 15, right man ni left na dire, downward ni upward dire, and counterclockwise ni clockwise dire. Like this one. And then, okay, kaya yun. Balancing. Balance naman ng 15, so wala na tayo normal dire or axial force. Ang vertical na lang or shear ba. So shear dire, upward na sa downward. And magbalance na ni 160. 160 clockwise, 160 po dire counterclockwise. Kaning red na yun, mo na i-transfer nimo sa BC. So for BC, reaction niya 36, i-transfer na nimo ang 4 og 160. Up po, downward ni upward na dire. O niya ang 160 na counter clockwise na dire. And then check na yun. 4 times 10, 40 man, di ba? Kanya na kay 4 o 36, 40 sad. And then i-check ni mo moment. 4 times 10, 40 times 5, that's 200. Di ba? 40 times 200. Against 4 times 10, 40 plus 160, 200 also. So, 0 na dire. And then shear moment and axial force diagram din. Okay, EB, mamani no? And then BC, wala nang joint B. And then diagrams, shear, going to the left 25, and then no load, lang straight, and then downward, assuming to the right 10, so 15 na lang, 25 minus 10, 15, no load, and then 15 there, naka 15 there. And the next moment, so you get the area of this, 25 times 4, that's 100, no? So straight line, 100, and then area of this, 15 times 4, 60, plus 100, and you have 160. To be balanced by this 160. Positive man eh. The beam smiles. And then, axial force diagram, compression ng 4, so negative. And then, no other axial force. And then, for BC, shear diagram, upward 4. And then 4 times 10, 40. So, you have negative 36. And then, 36 reaction, 0. And then you solve for x. My technique, 4 divided by 4, it's 1. And then, moment diagram, nakay 160 daan, no? 160 na siya. And then, i-add ni mong area, 1 half of 1 times 4, it's 2. Plus 160, so you have 162, no? Remember ang curvature, ang curvature is concave upward, pero downward, no? Pero kay positive man na area, i-mirror ni mo, so concave downward na siya, going up, kanina. 162. And then area of this, one half of 9 times 36 is 162. Negative man eh, so ma-zero siya din. Ang curvature niya, concave downward, going down. So, as is lang. And then, you don't have axial forces, so, kana lang zero. And then finally, the combined moment diagram. This one, and then this one. Mana siya ang combined moment diagram. Okay, the third problem is this. What will you do if you have an inclined member but the load is vertical or horizontal? Not perpendicular to the member. So, how are you going to analyze the problem? So first, again, you start with reactions, Rex, Ray, and Rc. And then, kapag force, since you have this horizontal load, okay, get the resultant, that's 40 times 3, 120. And therefore, to the left, yeah. And then, sa kapag moment, RC times 8 minus 80 times 6 minus 120 times 1.5. RC is 82.5. And summation of force sa Y. RAY is negative 2.5. Therefore, is directed downward. So, muna yung reactions. Okay, so using this result, the frame is then sectioned into two members, EB and BC. So this is member EB. Now, anyway, internal forces pa man eh, ang atong cutting section, dili lang perpendicular sa member, later na. So, horizontal lang or vertical, depende, pwede ra. Basta dili lang perpendicular sa member. It's either horizontal ang cutting section or vertical, pwede ra. So, check. Horizontal forces, 120 and 120 balance na. So, wala na horizontal na internal force dire. Vertical na lang. Okay. Natin 2.5, so natin 2.5 dire. Downward ni sa upward. And then, moment na yun. So, ang moment na to, counterclockwise is 120 times 1.5. That's 180. And 2.5 times 4, 10. So, 190 na, no? 120 times 1.5, 180 plus 10. 190 counterclockwise. Ang 120 is clockwise, 120 times 3, 360. 360 ang clockwise against 190 na counter. Therefore, there's a net moment of 170 clockwise. Clockwise na 1. 360 man clockwise, 190 lang counter. So, na 170 na clockwise. So, i-balance na to og 170 na counter. And then BC, transfer lang na to no? Transfer na to upward na downward eh. And then counter na clockwise. Let's check if we are correct. No? Summation of force sa Y, 80 o 2.5 balance. Moment dayon. 80 times 2, 160. 2.5 times 4, 10. 160 plus 10, 170. Counter, 170 na clockwise, so 0 ta dire. After this, shear moment and axial force diagram. Okay. So, you need to be detailed sa analysis nimo for inclined members. Okay? You have to understand this one. This is the most difficult part. Okay. So, this is the resultant of our uniform load, 120. Diba? So, internal force is 2.5 and then 170. Now, since this is inclined, our diagram, when we draw the shear moment and action force diagram, the axis must be perpendicular to AB like this one. Ah, sorry. I'm very busy sa. And transfer lang eh. Ana. Okay. Oh. Diri atong axis karon. So, mo ni atong local axis, local x o local y axis, ba? Okay. So therefore, kini mga loads nato na vertical and horizontal, we have to get components of this along or parallel sa axis, sa local axis, and perpendicular sa local axis. Okay, let us start with this. I mean, solve for theta. Ang theta nato is this one, no? Namatay 3 is to 4 na slope. So, therefore, the length of AB is 5, diba? So, we have a 3, 4, 5 triangle. And since theta is referred from A, ang cosine nato sa theta is 0.8, 4 over 5. This one, no? 4 over 5. And then ang sine is 3 over 8. Okay. Okay. So, 120, mo na yung theta. Amo na yung components. And since nadi ang theta, cosine 0.8 times 120, you have 96. Sine man 0.6, 3 over 5. 0.6 of 120, that's 72. And then, this one, theta ni theta sa so cosine 120 times 0.8, 96. 120 times 0.6, 72. For this one, not there is theta. Ano man, theta, 90 minus theta, theta ne. So cosine is 2.5 times 0.8, you have 2. 2.5 times 0.6, 1.5. And then last is this, 2.5. Another yung theta. So this one is cosine, no? 2 and then 1.5. So, simplify. Okay. Ang 72, dili man siya concentrated. Originally, kay uniform load man na. So, we have to convert 72 to a uniform load. So, ana, no? So, ang magnitude, since mo na resultant, i-divide ito sa 5, mo na ang magnitude sa uniform load. 72 divided by 5 is 14.4. Eh? And then, ang K96, same also. Kaya dili mo siya concentrated, uniform mangyapon eh. Bali components man siya uniform load. So 96 divided by 5, 19.2. Ang pag-draw sa kini na uniform load singa na ano. Ana upward 19.2 siya. And then finally, combine na to ni 1.5 og 96, have 97.5. And then opposite man natay net na 70. And then sa point B, 1.5 and then 2 plus natay moment na 170. Pwede na ka mag-draw sa shear moment ng axial force diagram. So 70, 14.4 times 5, 72. So negative 2 and then nakay 2 diha. And then solve for x. 70 divided by 14.4. You have this 4.861. So 0, get the area. 1/2 of 4.861 times 70. Kana 170.14. And then minus this area. And the result is 170 to be balanced by this. And then axial, this is tension ba? Pala, away from the joint one. Okay? And then tension, and this is opposite, so ana, and then tension man i-balance man niya, positive. Mo ni mo axial force diagram. And for BC, downward, no load, so horizontal, downward, and then no load, and then upward, close, movement, get the area of this, 170, 170 sa, and then area, 2.5 times 2, that's 5, no? So 170 minus 5, that's 165, and then 82.5 times 2 is 165, so 0. Sa actual, wala, no? And then last is the combined moment diagram. This one, and then this one. Okay? Again, this one, and then this one. Okay. So, dire ang most difficult part sa frame pag na-incline member. So, mo ni ang buhato nimo. Okay. Uniform load, i-resolve, get the resultant sa, and then break ito components, and then convert it back to uniform load. And then make sure that dili ka ma-wrong sa components diri sa imong reactions and the internal forces. Last, how to analyze a frame if there is an overhang. Eh? Uh, so again, you start with the reactions AX, AY, and then D. So sa X, you only have two forces, RAX and 10. And then moment, you get the resultant of this 2 times 16. You have 32. So RD times 12 minus 32 times 8. Now 1 half of 16 minus 10 times 8. And RD is equal to 28. And then summation of force of Y. You can solve for RAY. It's 4 upward. So money mo reactions. And then section nimo into 4 members, EB, BC, CE, and CD. So you start with member EB. This one, okay, 4, 10. 10 keeps na load. Okay, check. Horizontal, balance na. Vertical, upward, so na kay downward. Moment na yun. Counter, 10 times 4. Clockwise, 10 times 12. 40. 40 ang counter. Clockwise is 120. So there is an unbalanced moment of 80 clockwise. So i-balance na to og 80 na counterclockwise. And then BC, cut ka sa B, cut ka sa C. Transfer ni upward on 4. Ang 80 is clockwise na. And then get the resultant 2 times 12, 24. So 4 upward, 24 downward. Sobra og 20 downward. So 20 upward ni. And then moment na yun. 24 times 6, that's 144 counter clockwise. 4 times 12, 48 plus 80, 128 against 144. There is an unbalanced moment of 16 counter. So i-balance na to og 16 na clockwise. Okay. I-144 man ang counter. 12 times, 24 times 6. 144. We only have 128 clockwise. So, kulang tag 16 na clockwise. Okay. This is what you will do if there's an overhang. Before ni make, the last member should be CD. Yeah. The last member that you will analyze should be CD. So, i-catch ani mo daan na CE. Analyze first, sorry. Rather, analyze first member CE. And then the last member is to analyze is member CD. So, CE, resultant 8. So, nasa kay upward 8. And then, moment is 8 times to 16 clockwise. So, i-balance ito o counter na 16. So, pag transfer sa CD, ang forces dire, kung unsa ang net anin duha, i-transfer dire. Like for example, ang 20 og 8, ma-add man 28 siya upward. So, pag transfer, downward siya, 28. However, ang moment, cancels out. So, na-cancel siya, no? Clockwise o counter. So, 0 ang moment. Wala sa tayo moment daan And to check for member CD, okay, no? Check siya, kaya we only have 2 forces man. So, our analysis is correct. So, muna buhaton, if there's an overhang, i-analyze una ang overhang, aya ka mo proceed to last member. After this, diagrams na dayon. This is member EB, money atong internal forces, and then BC, transfer na dire, and then dire, 20 and 16, and then CE, kana, and then CD then. Diagram na yun ka. So, shear, you have 10, and then no load, and then minus 10, so mag-0 lang na. Okay. And then movement, yet the area, 10 times 8, 80. And since wala the area, so constant lang. And then balanced by this, 80 na niya. And then axial, 4 is compression, negative, tapos wala ilain, no other axial force. And then there, 4 side compression also. And then BC, 4 upward, and then 2 times 12, 24, negative 20, and then atay 20 na shear, and then X, 4 divided by 2, so 2 na siya. And then moment diagram, natay 80, and then area, 1 half of 2 times 4 is 4, plus 80, you have 84. And then this area, 1 half of 10 times 200, it's 100. No? So 84 minus 100, you have negative 16. Negative sa niya. And then axial force, wala man tayo axial, so as is lang na. And then CA, natay 8. And then uniform load, so straight line lang. Tapos moment, negative na siya daan. And then area, ano no? Ano mo na? So, concave, kwanta. Concave downward, going up. And then, as is ang atong axial. Member CD, wala tayo shear, wala siya tayo moment. Axial ra. So, negative siya, compression. And then last is combined a movement diagram. This one, this one, and then mao na siya. Okay. Okay. So, I hope that you have learned some things situational problems like given a frame na naay concentrated load sa joint, dapat refer mo itong problem para na may guide. Problem also which involves inclined members, pwede mo refer ato. And then also if there's an overhang, pwede sad. So I hope na namin na-learn sa presentation and thank you for watching.